Good morning, children, or good afternoon, children. I am Mrs. Flavia Silvestra of St. Anne's. I'm going to take physics lesson force and pressure for you. We are going to we are going to learn about force and pressure. Where and all we are using force here. Force, look at the picture here. Okay, force I'm going to explain. Look at the picture here. Girls are one side and boys are one side. They have a big rope in between. Both are going to pull the rope, both the sides. They are going to use a force. They are going to use their hands. That means they are using muscular energy. What they are going to use? They are using muscular energy. Now both the sides they are going to pull each side. That is, boys are going to pull the rope in their side and girls are going to pull the rope in their side. They are going to use water, energy, muscular energy. By forcibly they are pulling each other in their own sides. They are pulling each other's side. They are using force. Forcibly they are doing. So that pulling force is called as force here. So in this chapter we are going to learn about part 1. In this chapter we are going to learn about force and pressure, which is very important chapter in physics. Like that we are going to recall some of our daily basis activities in our day to day life. What you do to make the football move? So you are going to use the force and you are going to hit the ball in your legs. You understood? So there also you are using force. Now we'll move on to the other chapter. That is next part of the lesson. We are going to see the different type of forces we are going to see. Topics covered in this lessons are force and then types of force. Now we are going to learn the definition of what is a force. Is nothing but as C is near the door and he is going to forcibly open the door. There also is using force. Now I am going to come. Now here we can say that force is defined as a push or a pull, or we can say force is a physical quantity that can change the speed, state, direction and dimension of a object. Now because of force, the physical quantity can be measured. It can change the speed or it can change the state and it can change the direction and dimension of the object also. It can be changed. So using force, the main under you can say that in one word we can say that force is defined as push or pull of an object. You can say like that also. So here the same boy, one of the boy is going to push the door and open. You are going to pull the door to close also. Both the things we can do over here. How to answer this question now? You can say when what is force, push or a pull of an object, or change of physical quantity, or physical quantity that can change the speed, state, direction, dimension, state and the speed. It can be changed. Next chapter, that is in the next topic we are going to handle. So the top some lines are missing. That is the following changes that force can bring. The top line is the following changes that force can bring. Change in speed. If someone pushes your bicycle, it starts moving faster. Note, force comes in notice when at least two bodies interact. Look at the picture. The boy is playing with the ball. The ball is also a physical a body or a particle or anything or any object. The boy is interacting with the ball and is playing with the ball. So there is two bodies in contact. That is, they are going to interact both the side, both the ways. Think of the boy is going to play with the ball and is going to put the ball or he is going to forcibly throw the ball. Then the ball will have the action. If he is going to throw the ball faster, the ball speed will increase. It will, in which direction he is throwing, that direction the ball will take place. That ball will move from one place to another. So it changes from one place to another place. Even the speed varies, and then the physical quantity it is changing is dimension also it will change. Even the state of the ball also changes. So the physical quantity of a ball, the speed changes, the state of the ball changes, and the direction changes. Change in state of the body. When you kick a football, it moves from one place to another place. So if you want to catch the ball also, somebody should throw the ball to us. Here the football we are going to keep in rest place, then we are going to kick the ball. Here the object, the ball is in the rest place. It moves from one place to another place. So when you are going to kick the ball, in what speed you are going to kick, the speed varies, even the state of place varies, and it moves from one place to even another place. You are going to kick the ball in one direction, and the fourth one is even the dimension changes. Next is change in dimension. When you blow metal red with hammer, for example, a hot rod or metal rod is heated up, then it's going to be beaten up with the hammer. It is a round rod. When it is beaten up, it's become flattened. Is it not? Here also, two body interact. One body is called as hammer, one more body is called as the red metal, which is heated up, and both are going to interact, be in the contact. Now I am going to keep the iron rod, I am going to hit with the hammer. The iron rod will change the shape. Here I want to tell one example. Daily you are going to brush your teeth, is it not? You are going to squeeze the paste from the paste and on the brush. As soon as you squeeze the paste from the paste, what will happen? The body of the paste will become different or not? Same thing. Even when two forces, with the force two bodies interact, even the shape of the body change. Okay. Next topic is change in direction. When you hit moving cricket ball, it changes its direction. Here I added a picture, driving picture. I am going to sit in a car and I am going to drive a car. Then I have to see the direction. I have to give indicator for left and right. I have to choose the direction, which direction I want to move from one place to another place. Same thing. A ball is placed on the ground. I am going to hit the ball or kick the ball. Okay. I will choose the direction. In that direction, I am going to forcibly kick the ball or hit the ball. While driving also, I am going to give the direction for the car. Here also two body interact. In this example, I am going to drive the car and car is my object. I am going to give the direction in which direction the car must move from one place to another. Here also two bodies interact. One body is me, another body is car. There I am going to give the direction. So forcibly direction change. Types of forces: contact force, non-contact force. There are two different types of forces. Some things we have to use our own hands, push or pull, then forcibly work will be done. Okay, then force will work. Some are non-contact forces. Without our contact, physical contact only, forcibly the work will be done. So that is called as non-contact forces. Non-contact forces also I will tell examples. Contact force is nothing but force that act only when two bodies on physical in contact. Physically they are getting contacted. For example, a ball and me. You're going to kick the ball or I'm going to kick the ball. Both are in contact. I'm going to drive a car and give direction. That car is one object and me, driver, is one more object. So that is called as contact force. Force that act only when two bodies on physically in contact. I'm going to push the door. Even there I am going to use the contact. Next, example for contact force, muscular force. I am going to have a bag and I am going to carry the bag and go. Next, frictional force. Here I am using, in muscular force I am going to use my energy to load a bag. Okay, next is frictional force. I am going to write. Light work I am using. Is it not? So here also direction is mentioned. Next, mechanical force, where work is done in the factories. So these are the examples of contact force. So top the words are missing. That is example of contact force. Please write. Example, mechanical force. Force exerted by machines. Example, turbines and idle power station. Okay, turbines and idle power station. So all the turbines, they'll be rotating. So in idle power station, that is called as mechanical force. Who all know about turbines? Those who don't know about turbines, Google and see what is turbines, what is idle power station also. You check it out and you understand the meaning of turbines and idle power station. So these things and all we cannot do. Human power cannot be done. Only machine can do like this huge work in factories. Those who don't know about turbines and idle power station, please message me. I'll let you know. Again, I'll take a class. Next is muscular force. Force exerted by muscles. Picking off school bag, doing some work in your hands, kicking off ball, all where and all we are using our human energy. That is our muscular power or muscular energy, muscular force. We will call it as muscular force. That is, even there also two persons are in contact. One is a body, a non-living thing or a living thing. One more is a human hands. So this is the example for muscular force. Next one, third one is frictional force. Opposing force that opposes the motion of one body over surface of another body. Now I am nice sentence. Opposing force that opposes the motion of one body over the surface of another body. That we are moving from one place to another, walking hardly. So there and all we are using water. Frictional force. Even when you are writing in a pen, okay, we are going to use forcibly. See, some handwriting will be very nice, some handwriting will be very thick. Okay, even I am walking, I can walk briskly, even I can walk slowly. According to my energy, according to the friction of the body, the force applies. If I am going to forcibly walk, the footsteps and all will be on the mud road. You must have seen that. Hope you understand what is frictional force. Where and all I am going to use my pen and I am going to write hardly, the impressions will fall on the paper. That is called as frictional force. Even if I am going to write lightly, even that is called as what? Frictional force. How much force I am going to use? How much force or energy I am going to make walk or run? Okay. So what all you can, you don't know or you don't understand, just message me. One day we will have a doubt session. For that, one app we have to download. I'll tell you, even I'll message you. Hope you will download that app and keep it ready. Okay, by the app I'll clarify your doubts. Forces that require a touch or contact to be applied are known as contact forces. Example, muscular forces and frictional forces. Muscular force, the force applied by the effort of our muscles. Example, lifting a box, pulling a bucket of water, pedaling a cycle. All this comes under muscular forces. Okay, a very important part of our life, force. Okay, a push is a force exerted away from the body. Example, eating a snooker ball, kicking a football. The force of an attraction or repulsion between two magnetic bodies due to their poles is known as magnetic force. Okay, another one definition. Okay, we use force also to walk, to lift our legs also. we are going to use force. So while walking also we are going to use force. Now we are going to learn about non-contact force. Force that act when is physical bodies not physically in contact. For example, wind is there, tree also is there. Wind will not touch the tree. We cannot see also. Okay. But the wind will wave the tree from one side to another side. Okay, now fruits are there in the tree, it will only fall, the leaves also will fall from tree to the ground. Nobody is forcing, the fruits or the leaves will get ripen and it will fall. So here nobody is forcing, nobody is doing any effect, it automatically, it is done by nature. That is called as non-contact force. Hope you understood, children. Look at the apple tree. The apples are falling from top to bottom. Here nobody is forcing the apple to fall down. It's directly falling down. It's not going any sideways. So it is called as non-contact force. In non-contact force, we are going to see different types of examples. Example of contact forces: magnetic force, electrostatic force, and gravitational force. In that, magnetic force you can see here, and then in electrostatic force you can see that comb with paper, and in gravitational force you can see the apple tree, apples are falling from the tree to the ground. Magnetic force will attract ion fillings and ion particles. In electrostatic force, the dry comb will attract papers when you comb with the dry comb in your hair. Next we are going to see about magnetic force. Force exerted by magnets on iron objects. So you must have seen many cranes in the road, it will be carrying things. So extracting scrap iron from the garbages. There also it will attract, here magnets will work as a major part, it will attract the garbage from the garbage place, it will attract all the iron particles and it will collect all the iron objects and segregate the dry waste and that is metal dry waste from the garbage. So from this what you understand, here nobody is forcing, only crane is working and the magnet is going to attract the metal things. No, nothing is forced. Just we are going to keep the magnet there. The magnet will attract the dry particles, that is metal particles. It will collect all the metal particles and segregate and it will clean the garbage. So what will happen? So here also nobody is forcing magnet to use your pull, push or force, nothing. It is only collecting. So automatically there is no contact from our physical body to the magnet. We are going to place the magnet in the crane. It will only collect all the garbages. So next is electrostatic force. I told you now only. A very good example for electrostatic force. Force of attraction or repulsion exerted between charged particles. Between same charge, repulsive. Between appropriate charges, it is attractive. Now take or head bath or shampoo your hair. Then you are going to keep your scalp dry. Then you are going to use a dry clean comb. Even the comb should be dry comb. You are going to comb in your hair. Then there it will have the repulsion. Both are, we are going to do it fastly. Then take some bits of paper on your ground. Just keep your comb on the paper. Because of that repulsion, the comb will have the attraction power and it will attract all the papers. You will see automatically small bits of paper will go stick in the comb. The comb should be in plastic. Keep on telling, the comb should be in plastic, the comb should be dry, even your scalp should be dry. If it is wet, this experiment will not work. You can do like this, then by that you can see that attraction, a force of attraction here. What is reflection exerted between charged particles? Even our head is dry and it is charged, the force will give charge for the comb, nothing, no current, nothing will be there, it's an ordinary comb. How will attract? It is having repulsion property. So between one charge to another charge, from their hair to your comb, you are getting repulsion. Then
between papers and your comb, you have attraction. Hope you understood, children. Next, gravitational force. Force exerted by earth by gravity on all objects. It is always attraction in nature. Yes, even when you are standing in a land or ground, the ground or the landscape, it is having gravitational pull, it is having gravitation. Now in a tree, fruit is there. When it's ripe, it will fall down automatically. When it falls, why it's not falling in sideways? It will fall always vertically because of the gravitational pull. It is always attractive nature. It is always attractive nature. Hope you understood. Next topic is muscular force. The force that is caused by action of muscles inside the body. It is also called as contact force. Animals Animals make use of the force to carry our physical task. So animals are used. Where and all we'll use animals? We'll use bullock carts. We'll use bullock carts or not? In the carts, we will tie the bullocks and it will only carry. Even donkeys will do the work. So here also it is using muscles. I am going to lift a bag. Even when I am going to lift a bag, I am going to use my hand. My hand consists of different types of muscles. I am going to push somebody with my body force. Even with my body, I can use muscle power or from a body's energy. Forcibly, I can push somebody. So here I am going to use muscular power. Hope you understood, children. What is muscular power? The force that is caused by action of muscles inside the body. It is also a contact force. We are going to touch each other. When you're going to push someone or when I'm going to do any work, when I'm going to carry a bag, I'm going to touch it. Both will have contact. That is called as contact force. Children, what all you did not understand, please message me. I will explain you. Those who understood from the beginning what all I told, you're going to take one 200 pages notebook and copy each and every point in the notebook. Then my class will go waste, children. You're going to copy. You understood? Animals make use of this force to carry out physical tasks. So, without touching any object or bear, even animals without touching the bullock cart, the ox will not move from one place to another. So, we are going to physically touch it. So, there will be a good contact between the bullock cart and the ox. Even when you're going to push the door door or to the wall, even we have to use our force. We are going to touch the wall, touch the door. Hope you understood, children. We are going to touch the door, then only you can push or pull the door. So physical contact is must. So in muscular force, physical contact is must. Without touching anything, we cannot use the muscular force here. So the force that is caused by action of muscles inside the body, it is also called as contact force. So even it is a human being or it is animals, without touching, without having contact, we cannot use the muscular force. We cannot use the force. Example, look at the picture. Animals like bullocks, horses, donkeys, etc. They are tied with the cart and they will pull the cart. Okay, you can see the picture. Hope you understood, children. So without having physical contact, work will not be done. We are going to use our muscles, muscular energy or muscular force to push or pull the object. Next, coolie uses muscular force to lift luggage. You are seeing coolies in the railway station. Okay, even he will carry bags. Even he will use his muscular force in his hands. Okay, look at the figure, children. Hope you understood. Next one is athlete uses this muscular force for running. He will also use force to run faster and faster from run from one place to another place. So he is also using the muscular force from running one place to another to speed up, uh, to give his body from change from one place to another place. He is forcing himself, is using his muscular energy to move from one place to another place. So here also he is using muscular force for running. Hope you understood, children. Hope you are writing all the points what all I am telling. If you get pictures when you're writing notes, you can stick also. No issues. Now we'll go to the question and answers. So here in first question, give two examples of each of the situations in which you push or pull to change the state of motion of objects. Give two examples of each of that is cut there. So you write the answer is we push a bicycle to move it. We pull the table to change the position. That is the answer. Second question, give two examples of situations in which applied force causes a change in the shape of an object. When we press the foam, its shape is changed. When we stretch the rubber band, its shape is changed. Next, third question. Third question is a blacksmith hammers a hot piece of iron while making a tool. How does the force due to hammering affect the piece of iron? The force due to hammering causes the change in shape of iron and iron can be molded in the shape of the required tool. Hope you understood the answer, children. Next, fourth question. The fourth question, name the forces, that is only cut there. Name the forces acting on a plastic bucket containing water held above ground level in your hand. Discuss why the forces acting on the bucket do not bring a change in its state of motion. Muscular and gravitational force act on plastic bucket. That is the answer. Sentences, the force acting on the bucket do not bring a change in state of motion because they are acting in opposite directions with equal magnitudes. Therefore, the net force on a bucket remains 0. So next class we'll meet you. Signing off by Mrs. Flavia Silvestra of St. Anne's. Thank you and have a nice day, children. Bye.